Okay, in this video we're going to talk about polynomial and also rational inequalities. So we did a little bit of work with polynomial equations. We saw quadratic equations. We saw a little bit bigger polynomial equations, and some equations with fractions in them, which would be rational equations. Now we're going to switch to inequalities. Now one thing you should be familiar with are some real basic inequalities, like linear ones. Like if I said, what's 3x plus 1 less than 7, right? And I said solve that. Well, that's a linear inequality. You subtract 1, so that comes over to the other side. 3x is less than 6, divide by 3, so x is less than 2, right? Real easy. Things you've been solving for a long time. But what if this is not linear anymore? Well, things get a little bit more complicated. And so we're going to have to look at how do we find the solutions to that. But also think about it. The solution is not one single value. The solution is all the x's less than 2. So it's essentially a set of values. So when you did this, you should have learned the interval notation. You said, okay, well, here's 2. I want everything less than 2. So that's there. I don't want to include the 2 itself. So that would be negative infinity all the way up to 2. And we'll put a parenthesis around the 2 to say that we don't want it, and there's always a parenthesis around the infinity. So we could write the solution in interval notation, or you could write it in this inequality notation. This interval notation is something you got to get more and more used to, something you should be somewhat familiar with already. And so just some of the things that went on with these linear inequalities. We're going to do the same thing with these higher order ones. Now, one part of solving these polynomials inequalities that are bigger than linear, say quadratic, cubic, etc., is the concept of this location theorem. This location theorem says, suppose that you have an expression that is continuous on an interval I that contains the numbers a and b. All that means is that you have some function that's all one piece, okay? The corresponding y values for, say, these x values, okay? A and b are the x values. The corresponding y values have opposite signs. That tells you the graph crossed the x-axis, basically. You know, it's this idea of, okay, here's the x-axis. Let's say I have a point here and I have a point here. Well, in order to get from point A to point B, you would have to cross the x-axis. If this one is a negative y and this one has a positive y, they have opposite signs, you'd have to cross the x-axis. Well, if you hit the x-axis, that means the expression is equal to 0, right? How do you find x-intercepts? You set your equation equal to 0. So the y value is 0 is the easiest way to say it. So that's this idea of this location theorem. But another way to say it is, if I have two x-intercepts, here and here, and I know these are the only two x-intercepts, then to get from point A to point B, I could either do this or I could do this. Now what that tells me is that my y values between here and here are either all going to be positive or my y values are all going to be negative. Okay? But they can't be both, because if they're both positive and negative between here and here, that means my graph would have to have done something like this, in which case it would have to have crossed the x-axis again. But if these are the only two x-intercepts, that is impossible. Okay? So that's this idea of this location theorem. Another concept that we're going to use, which is pretty much the same idea as this location theorem, is the idea that any expression, no matter what you think of, polynomials, fractions, whatever, any expression, the resulting value when you plug something into that expression has one of four possibilities. It could be positive, it could be negative, it could be 0, or it could be undefined, right? So you can get positive, negative, 0, or undefined, right? That's the general idea. So what we're going to do is we're trying to solve an inequality. So we're trying to figure out where something is greater than or equal to, less than or equal to, something. Well, if we think of it in terms of 0, right? Greater than 0, greater than or equal to 0, less than or equal to 0. Then we can say, all right, well, what if we figured out where we were 0, where we were undefined? and I'm talking about equal to 0 and undefined. If we could find these two things and check them off the list, then the only thing left would be, where is my graph positive? Where's my equation positive? Where's my equation or expression negative? Okay? And if you're thinking about what you're trying to do here and here, is you're trying to figure out, where is my expression, something that's on this side, greater than 0, so that's positive, greater than or equal to 0, that's positive or 0, less than 0, less than or equal to 0, negative 0, negative 0. All right. So by finding where we're 0 and undefined first, we then can say, all right, well then this is all that's left. Let's now find these and figure out how we answer what we're looking for. I know it's a little jumbled. I think when we start doing an example, it'll start making a little more sense. Okay. I'll give you a real easy example to start with, and we'll look at these steps that we want to go through. So let me say, how about solve 3x cubed minus 9x is less than 0. Now looking at this is not a linear inequality. We have x cubed. So this is a cubic inequality. So we got to do things a little differently than we're used to. So these are the steps we want to follow. First, get one side of the inequality to be 0. We already have that. Second, if possible, factor this polynomial. Now you're not always going to have a polynomial over here, but we're doing the instructions for if it's a polynomial. If so, factor this polynomial. So we can do that. I can pull out a 3x. I'm left with x squared minus 3. Okay. Then what's the next thing I do? I can say, all right, that's as far as that's as far as I can factor it. I could think of factoring this a little more, but we'll leave it. Let's say we factor that. That's as far as we can do. The next thing we want to do is determine where the polynomial is equal to 0. So now what we want to do is we want to actually try and solve this equals 0. Well, to figure out where it equals 0, we're going to use that zero product property, right? This is a polynomial equation. I got two things multiplied together equal to 0. So 3x equals 0, or x squared minus 3 equals 0. Well, this is going to yield x equals 0. This is going to yield x equals plus or minus the square root of 3. Again, I'm going to extract the roots. I'm going to move the 3 over, plus or minus the square root, and I get that. So right now I have three places where we're equal to 0, but that's not what we're looking for. We're looking for less than 0. All right, but remember, this expression will take on one of four possible values when I plug something in for x. It will be positive, negative, 0, or undefined. Now, this is a polynomial. Polynomials are never undefined, so you don't have to worry about that. We just figured out that these are the only three places where we're 0. So now all we need to do is figure out, where is it negative, and that'll answer our question, because less than 0 is negative, and that's what we're looking for. So then this is where we go to the next piece. Graph the points where the polynomial is 0 from the previous step on a number line and pick test points for the intervals. To explain that a little more, it's helpful to see it. So I say, okay, here's a number line. I'm going to put these numbers, negative square root of 3, 0, and 3 on a number line. What that just did is it divvied my number line up into 4 intervals. This interval, this interval, this interval, and this interval. These are x values. Okay? Now, based on that location theorem, these are also, if you were thinking about looking at this in the form of y equals 3x cubed minus 9x, these are the x-intercepts. They're where y equals 0. So if these are x-intercepts, and these are the only x-intercepts, then based off of that location theorem that we just talked about, between them, my graph is either always positive or always negative, but not both. So now, if I take some number in this interval right here, so this is negative root 3, so let's say negative 2 is inside there. If I take that number and I evaluate this expression at that number, meaning plug that in for x, and I get a positive, then every single number in this interval will give me a positive. I do the same thing here, so let's say negative 1, here positive 1, here I'll go 2. It doesn't matter what number you pick as long as it's in the interval. And see how the expression behaves if it's positive or negative, and then decide what you want. So I'm going to start by plugging negative 2 in. Get some space here. So if I plug negative 2 into this, it's going to be 3 times negative 2 times negative 2 squared minus 3. And so what do I get there? I'm going to get, this is going to be negative, times, this is 4 minus 3, that's going to be positive. So overall I get a negative. I really don't care what the answer is, but I do care the fact that I got a negative. So that tells me that this interval will yield negative values when I plug it in x. I do the same thing for negative 1. I plug that into the expression. So 3 times negative 1 squared minus 3. And I see what happens. This will be negative. This, which is 1 minus 3, will also be negative. So I would actually end up getting a positive. And so this yields a positive value. I'll continue that. I'll plug in 1. So if I plug in 1, the only difference is this is positive 1, this is positive 1. So this will be positive. And this would be negative. So I get a negative. Then I plug in 2. I'll go back to this. It's the same thing as this. It was a positive 2. So this is positive. This is positive. So then this is positive. So what am I saying here? Careful about what I'm saying. I'm saying that if I took any x between here, so negative root 3 and 0, any one of those x's, and I plug it into here, it will give me a positive answer. Now think about what did we want. What we wanted was this thing. We wanted to take an x, plug it in here. In order to satisfy this inequality, we wanted to get a negative answer, right? We wanted less than 0. Well, we know that here and here we will be less than 0. So what's our solution? Our solution is any x that sits in these two intervals. So that'll be the solution is the interval negative infinity up to negative root 3. That's this interval. And this interval, which is 0 to 3. Now we have parentheses. I have parentheses for a reason. Parentheses mean you don't want to include the values. Remember, root 3. My mistake. That doesn't change anything. It's just root 3. Root 3, 0, negative root 3. That's where this thing equals 0. We don't want to be equal 0. We want to be less than 0. So I don't want to include any of those values. There. So that's why I put parentheses around it. And infinity always has a parenthesis. So there's my solution. Okay, this next one's a little bit harder, but generally the same idea. Polynomial is a little bit bigger. I gotta do a little bit more work, but kind of the same thing. So think about first thing, make one side 0. So I'm gonna move this negative 7x squared over to the other side. So I have 2x cubed plus 7x squared minus 15x equals 0. Or sorry, is less than or equal to 0. That's the sign here. So make one side 0, I got that. Next, we want to figure out when is this side equal to 0 or undefined. Well, it's polynomial, so I don't have to worry about undefined. Equal to 0, though, would be when 2x cubed plus 7x squared minus 15x equals 0, right? I got to figure out that. Well, that's a polynomial, so I can factor out an x. I'm left with 2x squared plus 7x minus 15 equals 0. So then I can factor that more, put your parentheses up. So I got 2x and x. What am I going to do here? 5 and 3. So I'll go 5, I go 3, I got plus, I got minus, and that'll work out. So this is 2x squared, this is minus 15. Then the insides and the outsides together give me 7, positive 7x. All right, so what does that tell me? When is this 0? When x equals 0, when x equals 3 halves, and when x equals negative 5. All right, that's where we're equal to 0. Now, we want equal to 0, right? But we also want less than 0 as well. So now I got to figure out negative. So I got 0, and now I need negatives. So that's where we start doing this. We go, all right, well, here's negative 5, here's 0, here's 3 halves. Doesn't matter if we spread them out evenly or not, but I got 4 intervals here. This, 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 and this. So I'm going to pick a number from each one of those intervals. So if this is negative 5, let's say negative 6. 0, so let's go negative 1, 3 halves, I'll say positive 1, and then 2. So I pick numbers from each one of these intervals. I'm going to take those numbers and I'm going to plug them in to this expression. Whether I plug them into this expression or the factored form of this expression doesn't really matter, but I'm going to plug them in. I like plugging things into the factored form, and I'm going to see what kind of answer I get. So let's say x is negative 6. If I plug that into here, it's going to be negative 6 times 2 times negative 6 minus 3 times negative 6 plus 5. This is negative. This is negative 12 minus 3. That's negative. This is negative 6 plus 5. That's negative. So negative times negative times negative gives me negative. So this interval yields a negative. Now I'm going to go x equals negative 1. So negative 1, plug in negative 1 here. I'm going to have 2 times negative 1 minus 3, minus 1 plus 5 gives me what? Negative. This is going to be negative. This is going to be positive. So negative times a negative times a positive yields positive. And I'm going to continue that process. Plug 1 in. 1 in here is going to give me a positive. 1 in here is going to give me a negative. 1 in here is going to give me a positive. Positive, negative, positive. That's negative. Plug 2 in. Positive, positive, positive. Okay. Now, what did you want? You wanted to be less than or equal to 0. So what I want is I want negative, but I also want to be equal to 0. Remember, these are the 3 places that were equal to 0. So I want this, this, and this as well. So then what's my solution going to be? It's going to be the interval negative infinity up to negative 5. But I want to include negative 5 this time, because that's also part of what solves this. And I also want 0 to 3 halves, but I want to include each of those as well, because again, I want them to be equal to 0. So I want everything inside here plus this and this. I want everything inside here plus this up to negative infinity. All right, so in this one we have another inequality, but this isn't a polynomial inequality. We have a fractional or rational inequality, where on this side of the inequality here we have this fraction. And we start off the same way. We want to make one side equal to 0, which already is. Okay. Now the concept here is this. This expression right here can have one of 3 values. It could be positive, it could be negative, it could be 0, and it could be undefined. Okay? We want it to be greater than 0, which means positive. So that's what we're looking for. We're trying to figure out what x could we plug into here that makes this side positive, bigger than 0. So what we're going to do is figure out when is it 0, when is it undefined, then that'll help us figure out when is it positive and when is it negative, and we're looking for this one. Very similar concept as before. So first we want to figure out when is this thing equal to 0 and when is it undefined. Okay? Well, think about it. It's a fraction. The only time a fraction is ever equal to 0 is if the numerator is 0. So when is this going to be equal to 0? When 4 minus x equals 0. When's a fraction undefined? Well, the only time a fraction is undefined is if the denominator is 0. So that'll happen when x plus 4 equals 0. So we're finding when this happens and when this happens based off of the numerator and denominator being 0. So now you solve. So this gives me x equals 4, and this gives me x equals negative 4. So those two x values make it 0 and undefined, and that's it. There's no other x value that will make it 0 or undefined, which means every other x value will either make this thing positive or negative, and again, we're looking for positive. So now what do? We lay out our number line. We go, okay, here's negative 4, here's positive 4, and we're going to figure out, okay, we got 3 intervals here. 1, 2, 3. Inside these intervals, we're either all positive or all negative. We just got to figure out which one it is. So we're going to take an x value here, say negative 5. Here, say 0. Here, say positive 5. And we're going to plug it into this thing here. So for x to be negative 5, if we plug it in, we're going to go 4 minus negative 5 over negative 5 plus 4. Well, the numerator is 4 plus 5, which is positive. The denominator is negative 5 plus 4, which is negative. So overall, we get a negative. So we get a negative here. When we go with x equals 0, we get 4 minus 0 over 0 plus 4. So top is positive, bottom is positive. So overall, we get a positive. So that one's positive. Last one, x equals 5. 4 minus 5 over 5 plus 4. Well, this is negative, this is positive. Negative over positive gives me a negative. So this one's negative. So that means every x in this interval right here will yield a positive result for this fraction. Okay? And that's what we were looking for, right? We wanted this fraction to be greater than 0. Greater than 0 is positive, so that's where our answer is sitting. So I'm going to write our answer down. The solution is the interval from negative 4 to 4. Now the question is, what about this? What about this? Do I want them in my interval? Do I do a bracket? Do I do a parenthesis? Which one is it? Remember, this is where the function's undefined. This is where the function is equal to 0. We don't want to be equal to 0 undefined. We want to be just greater than 0. So parenthesis, parenthesis, don't include either of them. The key to making this whole thing work is that this side is 0. If you look at some of our previous ones, one side was 0 here. Look at another one side was 0. Okay? So looking at this, you gotta make one side 0. If you don't make one side 0, then this isn't going to work out. But then once you make one side 0, regardless of what's on this side, polynomial, fraction, whatever, you say, okay, when is this thing, whatever it is, equal to 0 or undefined? Get rid of those. Lay those out on your number line. Then the only remaining possibilities are positive and negative. So you figure out, okay, positive or negative in each one of these. Then you go back and say, well, what do I want? This thing, this inequality right here said, I want greater than 0. So I want positive, that's what I want. If I wanted positive or equal to 0, greater than or equal to 0, then remember, this is where
were equal to 0. So I would also want to include that. I want all these in here plus this. So that means I would put a bracket around this one. But we didn't have that here, so we did parentheses.